Hello, this is the video for special topics on data analytics, and we are going to discuss about content-based recommender system. We will learn those things in this PowerPoint. So you're going to learn about what is content-based recommender system, and yeah, we are going to learn some of the topics related to the content-based recommendation system. For example, what is content representation and how to look at the item similarities. And we are going to learn about UTF, IDF, term frequency, inverse document frequency, how to improve the vector space model, and some methods on the recommending items. For example, yeah, we are going to look at the nearest neighbor. So we already learned about this one. And we are going to learn about Rocky's method. We are going to learn about the probabilistic method. So how to look at the Boolean factor or terms counts. I think we already learned these things before as well. And the linear classifier and how to look at the decision models. So what is content-based recommendation? If you already learn about the collaborative filtering, CF. Yeah. So the CF, it can be referring to the methods that do not require any information about the items. We just rely about the rating. So we just rely about the rating given by the users. The idea is it might be reasonable to exploit such information. It means it is maybe good if we have the information detail about the item. Okay. For example, yeah, if we know about a novel, for example, I know that novel is the fantasy, or maybe the novel is about the politics, or the novel is about the romance. So we know that people, yeah, who like fantasy novels in the past, they will like the fantasy novels in the future. Okay. So what do we need? So some information about the available items. So we need to look at the information. What are the information that the items have? For example, in the movie, we have genre, or maybe in books, okay, they also have genre. Or maybe we can also have some information about the user. For example, the user profile. So it describes what the user like. For example, the preferences. So the question or the idea in the content-based recommender system is show me more of the same what I have liked. So if I like the previous one is about action movie, then in the future I would like to also like the action movie. If I already watch about romance movie, then in the future I probably like also romance movie. So that's the idea. So we can put the contextual parameters and the user profiles into the recommendation component, and then we can make the recommendation list. So the task is to learn the user preferences. User preferences means we have the information about the maybe genre or any item about item information. And we can look at recommend items that are similar to the user preferences. So if the item or the genre are similar, then we can recommend those to the respective users. And you need to know what is content. So we call CP. Okay, CP is a content base. Okay. CP means a content base. Recommendation techniques were applied to recommending the text document. If we learn about the text analytics, we will have the same idea. If we are dealing with the content base, most probably we will deal with the text. For example, web pages or news group message, for example. The content of items can also be represented as text document, and we are going to look at more on the textual description with their basic characteristics. And sometimes the text, it will be in the structure or it will be in the separate column, for example, like this one. So each item is described by the same set of attributes. Let's say, I have this book title, and the genre is like memoir, and this is the author. Type is whether it is a paperback or hardcover, and we have the price, and we have the keywords. So the keywords are the text that mostly appear in the book. For example, it is related to press and journalism. It is related to drug addiction. It is personal memoirs, New York, okay, and so on. So in this case, we can look at the structure people already put in the specific table, but there might be unstructured, for example, free text description. In order to look at the details, so we can have the item representation. What we just look at the previous table, it is representing the item representation. So it's of the item that is book. We have more representation. For example, if the person likes this memoir genre, maybe in the future he also will like the memoir genre. Or maybe about the author. If someone like the author of this book, maybe this book, the author is David Carr. Then if someone like this book, maybe in the future the person will like any books authored by David Carr. Or maybe about the paperback or hardcover, because the person like book with paperback, maybe in the future the person also like the book related with the paperback type. Or maybe we can also look at the price. If someone like the book which is lower price than $30, for example, then in the future he also may like book with the price less than $30. Or we can also look at the keywords. So the keywords is also one of the things we can look at the similarities. It's also related with the user profile. So the user profile, we can build the user profile. For example, okay, this user like any book related to fiction. So this user like books where the authors are Bruno Rina, Perry, and Ken Follett. So this user like books which has the type paperback, and this user profile like books in the average price is 25.65. And this user like books related to the detective, murder, and the person has more books related to New York. So if we have this kind of user profile, then we can look what would be the best recommended books in the future. So the simple approach is we can compute the similarities of an unseen item with the user profile based on the keyword overlap. So for example, we can use the size similarity, or we can use the Chakart similarity. In this case, we can use the dice coefficient. So if we have the keywords in one document, we want to know the intersection with the keywords in different documents. And then we will take a look on the number of the keyword in BI, the number of keyword in the PJ. And then Okay, we can look at the similarities based on the keywords. So based on the keywords, we can look also the similarities of particular items. Or yeah, we can use and combine multiple metrics. Let's say I want to combine with between the dice and checkered similarity. We can also combine not only with the keyword, but we can also combine the similarity with other kind of attributes. So the similarity matrix, I think you already learned before. For example, we have the dice coefficient, and we have the cosine coefficient, and we have the checkered coefficient. So yeah, you can try to revisit again. So we already learned this one in the first section of the special topics on data analytics course. We can also use the other way to calculate the similarity is using the TF-IDF. TF-IDF means term frequency inverse document frequency. So we call it TF-IDF. Simple keyword representation has its problem. So it means if we use only keyword appears or not appears. So for example, if the keyword appears, then we put 1. If the keyword does not appear, we put 0. So if we just put 1 0, it has problem. In particular, when automatically extracted as not every word has similar importance. For example, if we have the high frequency of some words, for example, the word artificial intelligence, okay, the word AI. There are so many words of AI. Let's say there are 10 keywords of this one, but there is very small keywords about a robot. Okay. Maybe the word robot appears only one time. So actually, there are many cases when robot are related with the AI, but the frequency are different. So we can use the TF-IDF to make some kind of normalized values. And the other things, longer documents have a higher chance to have an overlap with the user profile. So if it is related with the very long text, okay, so maybe it is a description. It is a description about a book that has been sold in the bookstore for a long time. So if the documents has a very long text, then it's very tough to look at with the 0 1. So we can use the TF-IDF to look at what are the most probable keywords that overlap. Okay. So the standard measure, we use the TF-IDF, okay, and we have the encoding. Okay. We have the encoding method. So it means we are going to encode the text document into the multi-dimensional Euclidean space. It means we will put each of the factor, okay, we will put the width. So if it is in the document 1, maybe the width in document 1 will be different with the document 2 because of different number of words, different frequency of the words, or maybe it is different when the document 1 has more is longer than the document 2, and so on. So we have the TF. TF means how often a term appears in the document. So it is assuming that the important terms appear more often, and we will normalize it. Okay. So the normalization has to be done in order to take the document length into account. And we will have IDF. IDF is a method that aims to reduce the weight of terms that appear in all documents. So this is the idea of the TF-IDF. Given the keyword I and a document J, so we have TF-I, J. And yeah, it is the term frequency. The term frequency means how many. Okay, so like I mentioned, if the word AI, yeah, there are 10 times appear in the document, so we can just put the numeric 10. If the word robot, it appears only 5 times, then we put 5. Okay. And inverse document frequency calculated as the IDF log n means the number of all recommendable documents, and ni, it is the number of documents from n which the keyword I appears. So how many times that the keyword appears in the document. So the TF IDF means we are going to have the TF value multiplied by the IDF values. Now we can see, yeah, this is one example of the term frequency. In the term frequency, each document is a count factor. For example, this is from a drama, the Romeo and Juliet. Oh, sorry, this is from the drama Hamlet. So there is a script from the Hamlet, and then okay, the word Anthony. Oh, this is the drama. Okay, this is the book related to the things. So how many times the Anthony appears? Okay. So this one, yeah. And then how many times Brutus appear? Okay. And then how many times Caesar appears? Yeah. Yeah. How many times Calpurnia appears, and so on. Okay. So we can put this value, okay, to the document factors. And once we have the count factors like this one, then it means I have the 7 dimension, 1, 2, 3, 4, 5, 6, 7, and yeah, we can do more things related to this. So we can deal with the IDF. Okay, so if we have the TF, we have the IDF, and then we can do the multiplication. So this is very high number. So let's see with the small number of data. Okay. Let's say we have 3 comments. Okay. Let's say we have just 3 keywords, maybe the 3 comments. So let's look at the how we can calculate the TF-IDF. So the movie is good, the movie is very interesting, and the movie is very special for our family. Okay. Then we can calculate the TF, and then we can calculate the IDF, and then we can calculate the TF-IDF. So let's look at how we can calculate this step by step. First, we need to calculate the TF. The TF means the term frequency. The term frequency, usually we have the count. Count means the number of times the term appears in the document. So for example, we have the word, yeah, the movie is good, very interesting, for special our family. So we can calculate, let's say for the word the, there is 1, for the word movie, there is 1, the word is, there is 1, the word good, there is 1, and so on. Okay. So we can calculate with the count, and then we can calculate with term frequency. The term frequency means the number of times that the term appears in the document divided by the total number of unique terms in the document. So we know that the unique term here, there are 4. Okay, 1, 2, 3, 4. Then this 1 divided by 4. 1 divided by 4, 1 divided by 4, 1 divided by 4. For this one, we have the unique the unique word here is 5. So we have 1, 2, 3, 4, 5. So 1 over 5, 1 over 5, 1 over 5, 1 over 5. Yeah, luckily those are unique for every word. What about if there are some words appears some times, okay, so appears several times. For example, I have a dog. My dog is very cute, and I love my dog. Okay. So if it is one text, okay, if it is one text, or it is in one document, then the number of unique words we can measure it as 9. Why? Because I have a dog. So you can see dog there are 3 times. Okay? And yeah, mine is very cute love. So it is unique. So the unique are 9. So we can calculate the TF that for the term dog. It is 3 divided by 9. Then the number is 0.33. So it is how we can calculate the TF when there are several words appear in the document. So we can also look at the IDF. Okay. So if we deal with the IDF, means we can see out of 3 documents, only 2 documents contain the term very. So you can see the movie is good, the movie is very interesting, the movie is very special for our family. So the word movie, or the word you can see also. The word very, there are 2. The word movie, there are 3. So if we calculate the word very, you use the formula, the IDF means log of the total number of documents. So the total number of documents, there are 3. Then the number of documents containing the word, oh, sorry, not the word photo, the word very. Okay. So yeah, the word very. If the word very there are 2, then we divide with 2. Okay. So we want to know the log 3 divided by 2, then the value is 0.176. Oh, sorry, I mistyped this one. 0.176. Okay, I will fix this one. Then if I have this IDF, at the end, we can just calculate the multiplication. Okay. So the multiplication means I want to look at the word. Okay. So I know the TF, I know the IDF, then I can calculate the 0.25 multiplied by 0. So the TF IDF is 0. I have the value 0.2, the IDF is 0, then it is 0. I have the in the TF documentary, it is 0.125, and the value multiplied by 0, then it is 0. So if you look at the value, let's say this one, okay. So very 0.2 multiplied by, okay, this one is actually 0.176. So if we multiply this one, then this is the result. Okay, so we have a value. I will fix this one later. And yeah, let's say I have the very interesting this one. So we have this value multiplied by this value, then we have a value here. But because this is 0, multiply with any value, then it will be 0. 0 multiply with any value will be 0. Once we have this, so we can look at the uh, TF-IDF values here. This is the result of the TF-IDF. So this is the TF-IDF for document 1. This is the TF-IDF for document 2. This is the TF-IDF for document 3. Then you can put this one as a factor. Okay, so this is the factor. So this is the 0, 0, 0, 0.119, and so on. And then this is the factor for the document 2. And this is the factor for the document 3. So the factor of document 2 you can see here, and the factor for the document 3 you can see here. Okay. So that's the way to calculate the TF-IDF. Some questions, yeah, we can discuss it in the class from 9 o'clock. So what is the difference between the raw term frequency and the normalized term frequency? Okay. So the normalized term frequency means we already have the division by the unique number. Okay. So we divide with the total number of unique terms in the document. So what is the difference between the raw means only the numbers like 10, or if they are like 100, okay, so we calculate the frequency. But the normalized means we will divide with how many unique terms in that particular document. Okay. So how do you handle the stop words when using the TF-IDF transformation? Okay. I have not explained well about the stop words in this class, but if you join the text analytics class, I guess you understand. So stop words means something that appears frequently, but maybe it is meaningless. For example, the, is. Okay. So the word the appears several times. So you can see the word the appears many times. The movie is good. The movie is very interesting. The movie is very special. So you can see also the word is. Okay? The word is also, it appears many times. So how can we handle this one? And okay, we will discuss what is the limitation of TF idea. Okay, so please take a look on this question. You can find the answer first, and we will discuss it during the class on Monday from 9 until 9:20. Okay, I will stop the video now and see you on the class.